Hello, welcome to my video. In this, I will go over the organization of this video series and summarize the topics that we will learn. To begin with, data structure is the study of data storage, management, and access. By data storage, we mean the way we use to store the data, such as whether we store the set of data as a one-dimensional array, multi-dimensional array, as a tree, or in other forms. By data management, we mean, for example, the insertion or deletion of a piece of data, or maintaining a specific ordering of the data. By data access, we mean the probing or retrieving the information of a given piece of data. Perhaps the most important point we should note before learning data structure is that data storage, management, and access are mutually dependent. Some ways we use to store the data facilitate some management or access needs, while making the other ones more difficult. For example, given a set of data, we decide to store them as an array in ascending order. We have 5, 7, 12, 13, another 13, and 28. This way of storage makes finding the maximum value among the set of data very easy. We simply just grab the last piece of data. However, it will make a data management operation, such as insertion, much more difficult. Consider that we're trying to insert 14 into the current set of data. In this case, we will need to perform 4 steps. First, we need to increase the capacity of the array by 1 to reserve space for 14. Second, we need to find the proper location to insert 14, such that the set of data remains in ascending order after the insertion. Third, we will move all data after the insertion location to clear up the space for 14. And finally, we insert 14. From this example, you can see that our decision of storing the data as an ascending array facilitates the data access operation of finding the maximum value. But it makes the data management operation for inserting a piece of data much more challenging. Unfortunately, there exists no single miracle data structure that can simultaneously optimize data storage, management, and access. As a result, we have to develop different types of data structures to satisfy different needs. For example, if we need to constantly access the dataset, but we rarely insert any new piece of data, then the data structure we have discussed above would be a good choice. Having said that, the learning objective of this video series is twofold. First, we will get familiar with different kinds of data structures and know which operations they're good at or they're bad at. And second, given the knowledge and a specific real-world application, we will know which data structure to choose. And of course, the ultimate goal of this series is that we can develop new data structures to tackle new challenges. This video series is organized as a linear sequence of different data structures. We will discuss array, linked list, queue, stack, hash table, search tree, priority queue, disjoint set, and graph. I put the data structures in this order simply based on the form of their internal data storage. For example, array, linked list, queue, stack, and hash table store the data in linear form, while the other ones store data in nonlinear form, such as trees or multidimensional arrays. However, the ordering is very personal, and you should be able to just jump into the topics you like. All right, that's all for this video. Thank you for watching, and look forward to seeing you in the next one.